In part two, I put the PowerPoint file for part two. Just watch that, click on each slide. There are videos, embedded videos in each slide that you can see quite interesting application of deep learning. And the last one, so it's self-explanatory. I don't need to explain them. You can watch them yourself. The last one was GPT-2, and GPT-2 was a language model that built by OpenAI, and it's a quite big language model, about 1.7 million parameters. Uh, Quite interesting. The top paragraph. We can listen to this in part two, but the top paragraph, this one, is written by
In a
human,
shocking finding, scientists
and
discovered a herd of unicorns living in a remote,
in
previously
the
unexplored valley in the Andes Mountains. Even more surprising to the researchers was the fact that the unicorns spoke perfect English. Discovered
right,
a herd of
and
unicorns
the
living in a
bottom
remote,
part, this part,
previously
is
unexplored valley
basically
in
written
the
by
Andes Mountains.
the model.
Even more surprising to the
Very
researchers
realistic,
was the
no
fact that the
grammatical error,
unicorns
and
spoke perfect
quite
English.
consistent with the rest of the paper. So it's quite
The
impressive.
unexplored valley the in the Andes
Okay, so let me tell you about, some application which is different from what we have seen so far in part one and part two. In bioinformatics, in health, which could be our concern now due to COVID-19, it is also quite important and useful. Very briefly, let me tell you that how our immune system works. When a cell in our body get sick, um, our basically our system transfers short peptide to the surface of the cell. And what is peptide? Peptide is a short sequence of amino acids. A sequence of amino acids is protein, and a short sequence between 8 and 15 amino acids is a peptide. So these peptides go to the surface of the cell. They're called the antigens. And our body, B cells, produce some antibodies for these antigens, and antibodies binds to the antigens, and basically that's the cue. So these antibodies could be vaccine, uh, and it has been tried clinically, and it was quite successful approach. So a recent work which was published last year actually shows that how we can use this spectrum and generate the peptide, you know, given this spectrum, how we can find the peptide. So this spectrum is generated by a device. Basically you have tissue of the body of the patient, and then this device will make this type of a spectrum out of that. We don't want to get to the details, but this spectrum is basically okay. Let me simplify this for you. Suppose that what this spectrum, the information that this spectrum tell me, is similar to uh, knowing that I have apple, I have orange, and I have some other fruits, and I have, say, for example, cucumber. And then I will tell you that the apple costs $1, and orange costs $2, and cucumber costs $5. And then I will tell you that I spent $3, and I spend $7, and I spend $1, you know. And so $7, $3 could be apple and orange, and seven could be orange and cucumber, and one could be apple. So these bars in this spectrum is like this. It's basically addition of the say weights of these uh, amino acids. I'm trying to simplify all of them. And out of that, I want to see which possible sequence of this amino acid could possibly generate this spectrum. So given the spectrum, I want to have this amino acid, and there are many methods to do this, but using neural network, uh, you know, we could have done. I mean, it was quite successful, and with pretty high performance. So potentially, this can be used to find vaccines for many disease, like cancer, for example. That has low abundance. Um, Exposure on the cell, on the surface of the cell, so peptides cannot be recognized by the body. So if you recognize the peptide, the antigen which caused this disease, you can manufacture this antigen and inject it to the patient, and immune system start to react to this. So it's a state of the art, and change the from about 7% to 38%, and from 20.9% at the amino acid level to about 64%. So it was quite successful using deep learning. So just I wanted to tell you that deep learning is not just for images and voice and language. It can basically use in many different useful applications. So we learned about, or we heard about GPT-2, which is a language model, and this language model is based on transformers, and we are going to learn about transformer in this course. So GPT-2 is layers of transformers, and GPT-3, which was just in the news about a month ago, is the biggest language model. 175 billion parameters. GPT-2 was 1.5 billion parameters. 175 billion parameters is twice as many neurons that we have almost in our brain. And it's a very large language model. And the demo that was basically presented is quite impressive. You can write a description of a program, description of the application that you want, and GPT-3 create code for that application, that particular application. Um, so here, basically, in the demo that they showed, they write, it, some description, and the model basically write JavaScript code, for example, for that application. So the description is that I want, to draw, um, a circle and a triangle and a house and so on and so forth. And it writes a code to do so. Um, this is another interesting things that they show in their um, demo, that they have a spreadsheet, and in this spreadsheet they have just some titles, and the title is company, ticket, ticker, and year founded, and the application will find the information and fill up the spreadsheet automatically. And also, you can ask a question from Wikipedia, and this application can find, the answer of your question, the paragraph which answers your question in Wikipedia. Okay, so I think that's enough to be motivated for this course, and then we start to learn different models.